Example problem 2 asks us to do the beta minus and beta plus decay of polonium-84. So the formula for the beta minus decay is going to be the initial AXZ notation for the initial atom. You're going to have the decay happen, which is the arrow, and then you're going to end up with A. So that's not changing from the initial atom. What is changing is that you're going to have Z plus 1 plus your first type of beta particle, which is going to be an electron antineutrino. So 0 minus 1 beta. And again, that is electron antineutrino. So that's the formula for the beta minus. We then have to do the beta plus. And so once again, you're going to start with the AXZ for the initial atom. A is not going to change, but what will change is that you're going to have Z minus 1 instead of Z plus 1. And then you're going to have plus, and then you're going to have a different particle. It's not the exact same particle because we have a positron emission this time. So it's going to be 0 plus 1 beta. And again, this is going to be a positron instead of an electron antineutrino. So two types of emission happen in beta decay, and that's really important to remember. So to work this problem, the first one that we're going to do is the beta minus decay. So 218, 84, PO yields. So we have A, which is not changing, and then we have Z plus 1. So 84 plus 1 is 85. And if we look on the periodic table of elements, we can see that element number 85 is astatine. So AT plus 0 minus 1 beta particle. And it's as simple as that. And so to do the other one, to do the positron emission, 218, 84 polonium yields. And so we have A, again, which is not changing, 218. Z minus 1, 84 minus 1 is 83. And if we look on the periodic table of elements and see what element number 83 is, we can see that it is bismuth. So Bi plus 0 plus 1 beta particle. And so that's your positron. And that is how you do beta positive and beta negative emission. Let me know if you have any questions about example problem 2.